A very good morning, students. Welcome to science session for class 9, and today in this session we are going to see the numerical problems in the first unit, second unit and third unit, that is measurement, motion and fluids. So let's see the numerical problems in the unit 1 measurement. Now for the questions you can refer page number 12, children. So let's go into the first problem. Let me read the question. Enian and Erilin argue about the light year. Enian tells that it is 9.48 into 10 to the power of 15 meter, and Erilin argues that it is 9.46 into 10 to the power of 12 kilometer. Who is right? Justify your answer. Now what is given, children? The speed of the light. We know the answer for the speed of the light. We know the value, isn't it? Speed of the light is equal to 3 into 10 to the power of 8 meter per second. Now 1 year consists of 365 days, isn't it? Now we'll calculate how many seconds are there in 1 year. So this is 365 into 24 is equal to 24 hours into 60 minutes into 60 seconds. So when you multiply, you will get this answer. Now this I have written this as, now see how many digits, 1, 2, 3, 4, 5, 6, 7, isn't it? So after 7 digits I have put a point. So 3.1536 into 10 to the power of 7 seconds. So this can be written like this. Now 1 year is equal to, so this seconds into the speed of the light, right? So when you multiply, you will get 9.4608 into 10 to the power of 15. So that is 10 to the power of 7 and 10 to the power of 8 will become 10 to the power of 15. So whose answer is right? Enian argument is right, isn't it? So he said that 1 light year is equal to 9.46 into 10 to the power of 15 meter. So Enian argument is right. So this is the answer for the first question. Now let's move to the second question. Now I'll read the question, children. The main scale reading while measuring the thickness of a rubber ball using vernier caliper is 7 centimeter and vernier scale coincidence is 6. Find the radius of the ball. So we are using the vernier caliper here, isn't it? Now we are using the vernier caliper here, and the main scale reading is given as 7 centimeter. Vernier coincidence is 6, and we know the least count, isn't it? 0.01 centimeter, and the zero error is nil here. There is no zero error. So here we are going to find out the diameter of the ball, right? So using the vernier calipers, the diameter can be found using this formula, that is MSR, main scale reading, plus vernier coincidence into least count minus the zero error. Scale reading is 7, vernier coincidence is 6, least count is 0.01 minus zero error is nil here. So when you multiply this, it will become 0.06, and with the main scale reading, you are going to add this. So this will become 7.06 centimeters. So the radius of the ball is 7.06 divided by 2. So the value will be 3.53 centimeters. So what is the radius of the ball? Radius of the ball is 3.53 centimeter. Next we'll move to the third question. Now the question is, find the thickness of a 5 rupee coin with the screw gauge if the pitch scale reading is 1 millimeter and its head scale coincidence is 68. So we are using a screw gauge here, and what is pitch scale reading? 1 millimeter. What is head scale coincidence? It is 68. Now we have to find out the thickness of the coin. So this can be calculated using the formula pitch scale reading plus corrected head scale reading. Right, now how will you find out the corrected head scale reading? The formula is head scale coincidence plus or minus the zero correction. Now here the zero correction is nil. So head scale coincident is 68. Now this should be multiplied by the least count, isn't it? So when you multiply by the least count, it is 68 into 0.01 millimeter, isn't it? So when you multiply, it will become 0.68 millimeter. Now how will you find out the thickness? This should be added to pitch scale reading. So we know that the pitch scale reading is 1. So 1 plus 0.68 will give 1.68 millimeter. So the thickness of the coin is 1.68 millimeter. Now let's move to the fourth question, children. So what is the question? Find the mass of an object weighing 98 Newton, isn't it? So what is given? The weight of the object is 98 Newton. We know the acceleration due to gravity is 9.8 meter per second square. Now what we have to find out? We have to find out the mass of the object. Now let's see the solution. Now what is the formula for the weight? Weight is equal to mass into acceleration due to gravity. Weight is 98. So we have to find out the mass, and G is 9.8. So M is equal to 98 divided by 9.8. When you cancel, it will become 1 divided by 0.1, isn't it? Now I have to get rid of the decimal, isn't it? So I'll multiply by 10 in the numerator and the denominator. So that will become 10 divided by 1. So 10 kg. So what is the mass of the object? Mass of the object is 10 kg. Now let's move to the second unit, that is motion. Now for the questions you can refer page number 25. Now let's see the first question. The question is, a ball is gently dropped from a height of 20 meter if its velocity increases uniformly at the rate of 10 meter per second square. With what velocity will it strike the ground? After what time will it strike the ground? Here the distance S is given as 20 meter and acceleration is 10 meter per second square. Now the initial velocity is 0, isn't it? So it is dropped from a height, isn't it? So the initial velocity will be 0. Now what we have to find out? We have to find out the final velocity V and also the time that it will take to strike the ground. Now let's see the solution. Now here we are going to use the third equation of motion. So this is the third equation of motion, isn't it? V square is equal to U square plus 2AS. V square is equal to initial velocity 0 plus 2 into acceleration is 10 into the distance is 20. So V square is equal to, when you multiply you will get 400. So V is equal to square root of 400. So this can be written as 20 into 20, isn't it? So V is equal to 20 meter per second. So this is the final velocity. Now we have found out the final velocity. What do you have to find out? We have to find out the time. Now using the first equation of motion, we are going to find out the time that it will take to strike the ground. V is equal to U plus AT. Now we have found out, just now we have found out what is the final velocity, isn't it? So 20, the initial velocity is 0, acceleration is 10, and we have to find out the time. So T is equal to, when you rearrange, you will get T is equal to 20 divided by 10, that is 2 seconds. So it will strike the ground after 2 seconds. Now let's move to the second question. Now what is the question? An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. Now what will be the distance covered and displacement at the end of 2 minutes and 20 seconds? Now what is given? The diameter of the circular track is given as 200 meters. Now what will be the radius then? Radius is equal to 200 divided by 2, that is 100 meters. Now the time taken for one round is 40 seconds. So that is also given, right? Now what we have to find out? We have to find out the distance and what is the displacement. Let this be the initial position in which the athlete is. Now after 2 minutes 20 seconds, how many rounds he takes? So that should be calculated. Now let's see the solution first. Here the total time that is given is 2 minutes and 20 seconds. So this minutes should be converted into seconds. So 2 into 60 into 20 seconds. So that will be 140 seconds. Now the time taken for him to complete one round is 40 seconds. So how many rounds he will complete in 140 seconds should be calculated. So that will become 140 divided by 40. So that is 3.5 rounds. So he will complete 3.5 rounds in 140 seconds. Right? Now what is the distance covered by him? So that should be calculated, isn't it? Because we are here to find out the distance and the displacement. So distance covered is equal to, since it is a circular track, the circumference should be taken, isn't it? So 2 pi r into, because he goes 3.5 rounds, isn't it? So that should be multiplied. So here 2 instead of pi, I am substituting the value 3.14 into the radius r into the round 3.5. So when I calculate this value, it will become 2200 meters. So this is about the distance. Now here children, look into the diagram. So this is the initial position. So he completes one round and come to this initial position, isn't it? Now after the second round also he'll be here. Now third round, again the initial position will come. Now for the 3.5 rounds, he will complete half the circle, isn't it? So from here he will reach to the final position. So this is the displacement that he covers from the initial position and the final position. So this is nothing but the displacement. So this is the diameter of the circle. So distance, so displacement is equal to the diameter of the circular path. So what is the diameter of the circular path? That is 200 meters. So distance covered is 2200 meters and displacement is nothing but the diameter of the circle, that is 200 meters. Now let's go to the third question. The question is, a racing car has a uniform acceleration of 4 meter per second square. What distance it covers in 10 seconds after the start? Now here the acceleration is given as 4 meter per second square. Now what is the initial velocity? He is starting the car, isn't it? So initial velocity will be 0. So time is given as 10 seconds. What we have to find out? We have to find out the distance that it covers in 10 seconds after the start. Right now what is the solution? We are going to use the second equation of motion. S is equal to ut plus half at square. Since the initial velocity is 0, this term will become 0, isn't it? So plus half into acceleration 4, the time is 10, so it should be multiplied twice, 10 into 10. Now here when you multiply this, you will get distance is equal to 200 meters. So the distance covered in 10 seconds after the start is 200 meters. So the distance covered in 10 seconds after the start is 200 meters. Okay, now we'll see the unit 3 fluids numerical problems. Now for the question you can refer page number 37. Now what is the first question? A block of wood of weight 200 grams float on the surface of the water. Now if the volume of the block is 300 centimeter cube, calculate the upthrust due to the water. Now here volume is given as 300 centimeter cube. What is the weight of the block? It is 200 grams. Now what we have to find out? We have to find out the upthrust. When you convert this into kg, that will become 0.2, isn't it? Into 9.8 is the gravity. We have to multiply by the acceleration due to gravity to convert it to kg force, isn't it? So that will become, when you multiply this, it will become 1.96. I have done the multiplication here, 1.96 Newton, because Newton is the weight of the object. So weight of the object is equal to the upthrust, isn't it? So this is the upward force that is acting when an object is immersed in the water, isn't it? So the upthrust here is the weight of the object, that is 1.96 Newton. Now let's move to the second question. The question is, the density of the mercury is 13,600 kg per meter cube. Calculate the relative density. Now what is given? The density of the mercury is 13,600 kg per meter cube. The relative density has to be found out. Now we know the formula for the relative density, isn't it? Relative density is equal to density of the mercury divided by density of water. Now the relative density of mercury is 13,600 kg per meter cube and the density of the water is 1000 kg per meter cube. Now here you can cancel these two zeros and when you do the calculation it is 13.6. Now here the relative density has no units. So the value, only the value should be written without the units because the relative density has no units. Now let's move to the third question. So what is the third question? The density of the water is 1 gram centimeter cube. What is the density in SI units? Now here the density is 1 gram per centimeter cube, isn't it? Now here we are going to express this in kg per meter cube. Now this, if it is converted to kg, 1 divided by 1000 kg, isn't it? Now this should be converted to meter cube. So 1 divided by now this is a meter cube, so this should be, centimeter should be converted to meter. So since it is a cube, 100 into 100 into 100. So this is 1 divided by 1000 when it is expressed in terms of multiplication. So this will come in the numerator. So when you cancel the zeros, the remaining is 1000 kg per meter cube, isn't it? So the SI unit of the density of water is 1000 kg per meter cube. If it is expressed in grams per centimeter cube, it is 1. But when it is expressed in kg per meter cube, it is 1000 kg per meter cube. Calculate the apparent weight of the wood floating on water if it weighs 100 grams in the air. This is the fourth question, right? So what is given in this question? The weight of the object in air is 100 grams. Now what we have to find out? We have to find out the apparent weight of the object. Now we know the formula, isn't it? In the fluid lesson we saw that the apparent weight of the object is nothing but the weight of the object in air minus the weight of the water displaced. When it is immersed in water, it displaces the water, isn't it? So we have to subtract that from the weight of the object in air. Now here the weight of the object in air is 100 grams. Now the weight of the water that is displaced is 0. Why? Because it is floating on the surface of the water. So the amount of the water displaced is 0. So 100 minus 0 is equal to 100. So the apparent weight of the object is equal to the weight of the object in air. So that is 100 grams. So far we have seen the numerical problems in the first 3 lessons, that is measurement, motion and fluids, isn't it? So look into this video carefully, children. So follow the pattern of solving the problem, that is you have to write first given, then to find, then the solution. So copy these numerical problems in your classwork. So that is your homework today. Complete this classwork. Write the question and solve the problem and submit this in the school office. It will be corrected and given back to you, children. See you in the next session. Thank you, children.